While you are sitting in your room right now, an unimaginable shadow 10 billion light years wide is floating silently through the deep cosmos. Every single astronomy textbook on planet Earth claims this giant cosmic shape is physically impossible, yet right at this second, space telescopes around the world are locking their high-powered lenses onto its exact position. Astronomers are staring at their computer screens in absolute disbelief because the fundamental law of space just shattered. If you love uncovering the real, unvarnished secrets of deep space before everyone else, subscribe to our channel right now. We dive into legitimate scientific discoveries every week without any fake hype, so you can always stay ahead of the curve. And to truly understand why this massive space structure is terrifying top scientists today, we need to take a step back and look at how we used to think our universe was put together. For nearly one full century, every astronomer on Earth agreed on one very simple rule about the cosmos. They called this rule the cosmological principle. And that sounds like a long and complicated name, but the main idea behind it is actually super easy to picture in your head. Imagine that you are baking a massive batch of chocolate chip cookie dough in a big kitchen bowl. If you take the time to mix the dough thoroughly, every single scoop you take out of that bowl will have roughly the exact same number of chocolate chips. You might get one scoop with 4 chips and another scoop with 3 chips, but you will never find an entire half of the bowl filled with pure chocolate, while the other half is completely empty dough. Astronomers were convinced that the entire universe was mixed together in that exact same even way. They believed that if you zoomed out far enough into space, the universe would look completely smooth and uniform everywhere you turned your telescope. Of course, when you look close up, you see local clumps of matter like our sun, our planet Earth, or our neighborhood galaxy called the Milky Way. You even see small clusters of galaxies held together by gravity. Scientists treated those individual stars and galaxy groups like the single chocolate chips inside the dough. They knew that local clumps existed, but they assumed that on a grand cosmic scale, everything balanced out perfectly. If you took a gigantic invisible box measuring 1 billion light years on each side and placed it anywhere in space, you were supposed to find the same total amount of mass inside that box no matter where you placed it. A light year is simply the total distance that a beam of light can travel through empty space in one full year. Since light travels at an incredible speed of 186,000 miles per second, a single light year equals nearly 6 trillion miles. That means a box measuring 1 billion light years across is a mind-boggling size of 6 sextillion miles wide. For many decades, mathematical formulas proved that gravity simply did not have enough time to pull together anything larger than 1 billion light years across. The universe is about 13.8 billion years old. Because gravity travels at the speed of light, it takes a massive amount of time for the gravitational pull of one object to reach another object across millions of miles of empty vacuum. And if you tried to build a connected physical structure larger than 1 billion light years wide, there simply had not been enough time since the Big Bang for gravity to drag all those distant galaxies together into one continuous shape. That size limit of 1 billion light years became an unbreakable law in modern physics, and it was taught as absolute fact in every single high school and university physics class across the world. Then a team of space researchers decided to map out the locations of the most powerful explosions in the known universe. These ultra-bright cosmic events are known as gamma-ray bursts. A gamma-ray burst happens when a supermassive star runs out of fuel and collapses into a black hole, or when 2 extremely dense dead stars collide with each other in a violent crash. When one of these cosmic explosions takes place, it releases more raw energy in just a few seconds than our sun will produce over its entire 10 billion year life. They shine like giant cosmic light bulbs, cutting through billions of light years of total darkness. Because these explosions are so exceptionally bright, astronomers can use them as bright map markers to chart where invisible matter is hiding across the deep void. Scientists fully expected these gamma-ray bursts to be scattered completely at random across the sky. They thought the map would look like tiny drops of rain scattered across an open driveway. They figured a few explosions would show up on the left, a few on the right, and a few in the center, creating an even random spread across all directions of space. And what they actually uncovered sent a cold shock wave through the entire astrophysics community. When they plotted the precise coordinates of dozens of these gamma-ray bursts, the map points did not look like random raindrops at all. Instead, a massive cluster of these powerful explosions lined up neatly together to form a colossal connected structure pointing toward the constellations Hercules and Corona Borealis. Did you know that a single dying star can unleash an explosion so bright it reveals hidden giant structures across the cosmos? If that incredible fact blew your mind, drop a comment below letting us know if you think our maps of space are wrong, and hit the like button right now. When astronomers measured the total length of this newly discovered space structure, the final numbers completely wrecked their existing physics models. The structure, which is now officially named the Hercules Corona Borealis Great Wall, stretches over 10 billion light years in length. To truly grasp how massive 10 billion light years really is, consider this simple comparison. When a single particle of light left the sun earlier today, it took roughly 8 minutes to reach your eyes here on Earth. If that same light particle traveled all the way to our nearest major galaxy neighbor, Andromeda, the journey would take 2.5 million years. But to cross from one end of the Hercules Corona Borealis Great Wall to the other, that light particle would have to travel for 10 billion full years. That single journey would take more than double the entire age of our planet Earth and our sun combined. It would take up nearly 3/4 of the entire lifespan of the universe since the Big Bang occurred. This single structure stretches across roughly 10% of the entire observable universe in one single direction. This shocking discovery created a massive gap between what scientists expected to see and what was actually hanging in the sky. Scientists expected that no object in space could ever grow beyond 1 billion light years wide. Instead, they discovered a real physical giant that is 10 times larger than the absolute maximum limit allowed by physical law. This gap matters tremendously because it suggests our understanding of how the cosmos was born and evolved might be deeply flawed. If a giant shape like this exists, ordinary gravity could not have assembled it in just 13.8 billion years. It would be like walking into a young forest that was planted 20 years ago and finding a giant redwood tree that takes 1,000 years to grow. The research team led by Hungarian astronomer István Horváth analyzed the satellite data again and again, convinced they were looking at a simple computer error. They wrote advanced mathematical programs to check if this cluster of space explosions was just a strange optical trick or a random coincidence, like flipping a wooden coin 50 times and getting heads every single time. And the final mathematical test revealed that the chances of this giant wall being a random fluke were less than 1 in 20,000. The data was overwhelmingly clear and solid. A gargantuan continent of galaxies was sitting out there in the dark depths of space, challenging everything we knew. Here's the exact detail that trips people up the most when they first hear about this discovery. The Hercules Corona Borealis Great Wall is not just empty dust or gas. It is a massive cosmic web containing thousands upon thousands of entire galaxies, all held together by invisible threads of gravity and dark matter. Dark matter is that mysterious invisible substance that makes up roughly 85% of all the matter in the entire cosmos. We cannot see dark matter directly with our eyes or telescopes because it does not emit or reflect any light, but its heavy gravitational pull acts like cosmic superglue, holding galaxies together so they do not spin apart. Scientists originally believed that dark matter formed a smooth, light scaffolding across the early universe, allowing tiny galaxies to form first and then slowly gather into small groups over billions of years. That classic idea was known as the bottom-up model of cosmic growth. What they actually found with this 10 billion light-year wall suggests that a top-down process might have taken place instead. It looks as though massive cosmic channels were already carved into the universe right at the very beginning of time, and galaxies formed inside those pre-existing giant tracks much later on. And think of it like building a modern city. The old theory claimed that people built isolated cabins first, and over hundreds of years, those cabins accidentally lined up into long streets and large cities. The new discovery suggests that giant highways were paved across the landscape first by some unknown force, and houses were built along the edges of those highways afterward. Have you ever wondered if the universe was organized according to a master blueprint before the first stars even turned on? Leave a comment right now with your thoughts on whether space was built on purpose or by pure accident, and subscribe to keep exploring these secrets with us. Just as astronomers were trying to make sense of the giant wall in Hercules and Corona Borealis, another mind-bending discovery made the situation even more urgent. A brilliant young researcher named Alexia Lopez at the University of Central Lancashire was carefully analyzing light coming from super-distant space beacons called quasars. Quasars are the insanely bright centers of far-off galaxies powered by giant supermassive black holes that are actively devouring huge clouds of gas and dust. They burn so intensely that they act like giant cosmic flashlights, beaming light across billions of light years of empty space toward Earth. As that intense quasar light travels through space on its journey toward our telescopes, it passes through hidden gas clouds and distant galaxies along the way. Specific chemical elements inside those gas clouds, like magnesium, absorb very specific colors of the quasar light. By studying which exact colors of light were missing when the beam reached Earth, Alexia Lopez could map out where invisible matter was hiding in the dark. Even if those distant galaxies were far too dim to be seen directly by standard optical telescopes, astronomers expected to see a completely smooth and random scattering of gas clouds floating mindlessly between Earth and those far-off quasars. They expected the light absorption map to look like dust drifting casually through a quiet bedroom. What Lopez actually uncovered was a gigantic, nearly perfect crescent shape made of thousands of galaxies stretching across 3.3 billion light years of deep space. This giant shape was officially named the Giant Arc. The giant arc is so enormously wide that if you could step outside on a dark night and see it with your naked eyes, it would span a massive chunk of the night sky, taking up a width equal to 20 full moons placed side by side in a row. This structure sits roughly 9.2 billion light years away from Earth, meaning we are looking back in time to an era when the universe was less than half its current age. Yet even back then, this huge crescent shape was already fully formed and standing proud in space. The gap between prediction and reality was once again totally staggering. Scientists expected the early universe to be even smoother and less organized than the modern universe because gravity needed billions of extra years to construct big things. Instead, they discovered a 3.3 billion light-year arc standing tall almost 10 billion years ago. The discovery of the giant arc proved that the Hercules Corona Borealis Great Wall was not just a weird one-time anomaly. Giant rule-breaking structures were popping up all over our space maps, and if you were standing on an alien planet inside that giant arc 9 billion years ago, what do you think your night sky would look like? Tell us your visual predictions in the comment section below, and do not forget to share this video with a friend who loves crazy space facts. Finding one massive rule-breaking structure in space was already a giant problem for standard physics, but finding a second massive structure right next door in the exact same neighborhood turned the problem into a full-blown crisis. While Alexia Lopez was still analyzing the data from the giant arc, she kept searching through deep sky mapping data from the Sloan Digital Sky Survey. She began mapping another region of the night sky located near the constellation Bootes. She fully expected the space surrounding the giant arc to be empty, quiet, and sparse, balancing out the extra mass of the arc to keep the overall universe nice and even. What she actually uncovered was a second colossal structure sitting right beside the giant arc. This newly discovered feature was given the name the Big Ring. The Big Ring is a giant, ring-shaped collection of galaxies measuring 1.3 billion light-years across, with an overall circumference of nearly 4 billion light-years. And if you could look up into the night sky and see the Big Ring with your naked eyes, it would take 15 full moons lined up end to end just to stretch across its center. When Lopez analyzed the shape in 3 dimensions, she found it actually looks like a giant corkscrew coil pointing directly toward Earth. Here's the precise fact that makes this double discovery so completely shocking. Both the giant arc and the Big Ring sit at the exact same distance from Earth, located 9.2 billion light-years away. They are separated on our sky map by only 12 degrees in cosmic terms. That means they are sitting right next door to each other, like two giant skyscrapers standing in the middle of an open field where buildings are not even supposed to exist. Scientists originally calculated that if an ultra-large structure ever appeared by pure random chance, it would be extremely rare, like a 1 in a trillion cosmic accident. You might find one single structure in the entire observable universe if you searched for 1,000 years. Instead, astronomers discovered two giant, law-defying structures sitting side by side in the exact same corner of space at the exact same point in cosmic time. This gap between scientific theory and real observation has now grown so wide that astronomers can no longer ignore it. Alexia Lopez publicly stated that current cosmological models struggle to explain even one of these objects, let alone two of them sitting right beside each other. Can you guess what powerful force might have caused these two giant structures to form side by side in deep space? Write your best scientific guess in the comments right now and make sure to subscribe so you never miss our updates on this growing mystery. Before these recent discoveries, astronomers had already spotted a few other large structures, but they foolishly assumed those were just tiny exceptions to the rule. One famous example was discovered back in 2013, known as the Huge Large Quasar Group, or Huge LQG. The Huge LQG is a massive collection of 73 individual quasars stretching over 4 billion light-years across. When it was first discovered by astronomer Roger Clouse, scientists argued bitterly about whether it was a real connected object or just a random grouping of unrelated spacelights. To make matters even more intense, Roger Clouse had previously found another large structure called the Clouse-Campusano Large Quasar Group, which stretches over 2 billion light-years in length. Each time one of these giant structures was announced, mainstream astrophysicists tried to wave it away, claiming that statistical methods were slightly flawed or that the structures were just visual illusions caused by looking through layers of cosmic dust. They clung tightly to their beloved cosmological principle because without it, the basic math used to calculate the age of the universe, the expansion rate of space, and the amount of dark energy suddenly becomes completely unreliable. If space is not smooth and uniform on large scales, then a measurement taken in one direction of space might yield a totally different result than a measurement taken in another direction. Imagine trying to measure the average temperature of the ocean, but every time you dip your thermometer, one bucket of water is freezing cold while the bucket right next to it is boiling hot. Your average calculation becomes totally meaningless. That is the exact nightmare scenario that cosmologists are facing right now. The foundation beneath their calculations is crumbling, and the universe is proving to be far more lumpy and complex than anyone dared to imagine. Here's the detail people remember most when looking at our local neighborhood. Even our own home galaxy, the Milky Way, is trapped inside a giant cosmic shape that we only recently managed to map out completely. Back in 2014, a team of scientists mapped the movement of thousands of local galaxies and discovered that our Milky Way is just a tiny outer twig on a giant cosmic continent called Laniakea. Now, the name Laniakea comes from the Hawaiian language, and it translates to immense heaven. This giant supercluster contains over 100,000 individual galaxies and stretches across 500 million light-years of space. All the galaxies inside Laniakea, including our own Milky Way, are being pulled along like leaves floating in a river toward a central dense region called the Great Attractor. The Great Attractor is a massive gravity well hidden behind the thick dust lane of our galaxy, boasting the gravitational mass of tens of thousands of Milky Ways combined. Yet even as vast and impressive as Laniakea is, it fits neatly under the old 1 billion light-year limit. That is why scientists accepted Laniakea without destroying their physics models, but objects like the Big Ring, the Giant Arc, and the Hercules Corona Borealis Great Wall are 10 to 20 times larger than Laniakea. Do you feel tiny knowing that our entire galaxy is just a small leaf floating down a massive cosmic river inside Laniakea? Drop your reaction in the comments below, hit the like button if you love learning about our cosmic home, and subscribe to join our space community. As if giant walls, arcs, rings, and superclusters were not enough to puzzle astronomers, strange movements of matter across the universe have added fuel to the fire. Scientists have discovered a phenomenon known as dark flow. Dark flow describes a mysterious, unexplained movement where hundreds of galaxy clusters appear to be traveling at millions of miles per hour toward a specific point far outside our observable universe. It is as if some gigantic, unseen mass sitting beyond the edge of our visible horizon is pulling a huge chunk of our universe toward itself, like a giant cosmic vacuum cleaner. Under standard physics laws, matter inside our observable universe should only react to gravity coming from objects inside our observable universe because information cannot travel faster than light. If something outside our visible bubble is pulling on galaxies inside our bubble, it implies that the structure of space stretches out far beyond what we can see, carrying giant imbalances that break all our simple theories. To make things even stranger, scientists mapping local space found a region called the dipole repeller. While the Great Attractor is pulling galaxies toward itself, the dipole repeller is an enormous empty void that seems to actively push galaxies away. Matter in our region of space is simultaneously being pushed by this giant empty void and pulled by massive superclusters, creating a high-speed cosmic highway stretching across hundreds of millions of light-years. Every single map we draw of the sky shows that space is dominated by giant structures, huge voids, high-speed rivers of galaxies, and law-breaking superstructures. The gap between our tidy textbook theories and the real messy universe is turning into a massive chasm that requires a radical new scientific revolution to solve. Have you ever wondered if something giant is hiding just beyond the edge of what our telescopes can see? Tell us your wild theories in the comments section right now, and make sure you subscribe so you never miss our deep dives into space mysteries. The arrival of NASA's James Webb Space Telescope has pushed this ongoing cosmology crisis into overdrive. When James Webb opened its giant gold mirror in deep space, its primary job was to look back in time at the very first galaxies that formed after the Big Bang. Scientists expected to see tiny, dim baby galaxies that were still struggling to gather gas and light up their very first generations of stars. They predicted that early galaxies would look messy, small, and disorganized. What James Webb actually revealed were massive, fully formed, brilliant galaxies sitting in the extremely early universe. Just a few 100 million years after space began, these ancient galaxies are so bright and contain so many mature stars that astronomers jokingly nicknamed them universe breakers. They simply should not exist so early in cosmic history according to the standard model. Just like the Hercules Corona Borealis Great Wall, these early galaxies formed way too fast. There was simply not enough time for gas clouds to cool down, collapse, form stars, and build giant galactic disks in the short window available. This discovery provides strong, direct proof that something fundamental is missing from our core understanding of how matter behaves and grows across cosmic time. Whether we look at the early universe through the infrared eyes of James Webb or scan the local sky with ground-based optical arrays, the message is exactly the same. Structure forms much faster and on much larger scales than our physics models allow. The standard story of cosmic evolution that we have relied on for 40 years is officially failing tests at every single scale of distance and time. Which space telescope do you think is making the most shocking discoveries right now? James Webb or ground-based sky surveys? Write your pick in the comments below, hit that like button, and subscribe to stay updated on all space news. To fix this giant hole in physics, scientists around the world are proposing wild new theoretical models that sound like pure science fiction. One intriguing idea being investigated right now involves theoretical objects called cosmic strings. Cosmic strings are not the tiny strings from subatomic string theory. Instead, they are colossal, infinitely long cracks or wrinkles in the fabric of space-time itself. These cosmic strings might have formed during the rapid expansion of the universe right after the Big Bang, when space froze from a super hot state into a cool state, similar to cracks forming in lake ice as it freezes on a winter night. A cosmic string would be thinner than a single proton, but a line measuring just 1 mile long could weigh more than the entire planet Earth. If a cosmic string was whipped through the early universe at nearly the speed of light, its intense gravitational pull could have swept up immense amounts of matter, snapping galaxies into long lines, giant rings, and huge arcs. If cosmic strings truly exist, the Big Ring and the giant arc might actually be the visible scars left behind by these ancient space-time cracks moving through deep space billions of years ago. Another fascinating theory comes from famous Nobel Prize-winning physicist Sir Roger Penrose, known as conformal cyclic cosmology. Penrose suggests that our universe did not just start once with a single Big Bang. Instead, Penrose argues that the universe goes through an endless cycle of births, expansions, deaths, and rebirths. One universe expands until all stars die, all black holes evaporate, and space becomes completely empty. At that ultimate point of total decay, the cold, empty space triggers a new Big Bang, giving birth to a fresh universe and an endless sequence of cosmic life cycles. Under Penrose's theory, giant shapes like the Big Ring or the Hercules Corona Borealis Great Wall could be gravitational ghosts left behind by supermassive black hole collisions that occurred in an earlier universe before our own was even born. How incredible is the idea that our universe might be built on the fossilized remains of an older universe that existed before the Big Bang? Share your thoughts on cyclic universes in the comments below and subscribe to keep exploring these mind-bending concepts with us. If you think gravitational ghosts and cosmic strings sound wild, consider another massive cosmic puzzle that has been troubling astronomers for over 20 years, the cosmic microwave background cold spot. The cosmic microwave background is the faint thermal radiation left behind from the Big Bang, filling every corner of the sky like a giant baby picture of the universe taken when it was just 380,000 years old. When scientists mapped this radiation, they expected to see smooth temperatures across the sky with only tiny variations of a fraction of a degree. What they actually found in the southern sky was an enormous, unusually cold region spanning nearly 2 billion light years across, known simply as the cold spot. Standard physics models calculate that the chances of such a cold spot forming naturally by random thermal chance are less than 1%. One exciting theory proposes that the cold spot is a supervoid, a colossal region of space that is completely empty of galaxies, dust, or dark matter. Another far crazier idea suggested by theoretical physicists is that the cold spot could be a physical mark caused by a collision between our universe and a parallel universe in a vast multiverse system. If two bubble universes bumped into each other during early expansion, that giant impact could have left a massive cold spot and pulled matter into giant structures across the sky. Whether the cold spot is a parallel universe bruise or a massive supervoid, it proves once again that the smooth cosmic map we used for decades is missing major pieces of the puzzle. Do you believe that parallel universes exist out there in a vast multiverse? Write your opinion in the comment section right now. Hit the like button if you love deep space puzzles and subscribe to stay on the front lines of discovery. Right now, as you are listening to this narration, the search for answers has shifted from quiet theoretical debates into a high-stakes global space race. Space agencies are building a brand new fleet of advanced observatories specifically designed to solve these cosmic mysteries. The European Space Agency recently launched the Euclid Space Telescope into orbit, tasked with creating the largest and most accurate three-dimensional map of the universe ever made. Euclid is currently surveying billions of distant galaxies across more than a third of the entire sky, measuring how dark matter and dark energy have shaped the cosmic web over the last 10 billion years. At the exact same time, the Vera C. Rubin Observatory in Chile is preparing to initiate the Legacy Survey of Space and Time. This powerful ground telescope uses the largest digital camera ever constructed to scan the entire visible southern sky every few nights. It will track billions of galaxies, record millions of stellar explosions, and map the positions of giant structures with unprecedented precision. In a few short years, NASA will launch the Nancy Grace Roman Space Telescope, equipped with a view of space 100 times larger than that of the Hubble Space Telescope. These advanced instruments will settle the debate once and for all. They will show us whether the giant arc, the Big Ring, and the Hercules Corona Borealis Great Wall are rare cosmic anomalies, or if the entire universe is packed with giant structures that our older telescopes were simply too weak to see. We are living through an active live transition period in modern science where the old rulebook is being rewritten line by line before our very eyes. The standard model of cosmology, which stood firm for over 40 years, is being challenged by fresh observational data that cannot be swept under the rug any longer. Are you excited to see the new maps of space that Euclid and the Vera Rubin Observatory will create over the next few years? Let us know in the comments below, and subscribe so you never miss an update when those new maps drop. When we zoom out from all the complex mathematical formulas, telescope measurements, and technical distances, this cosmic discovery connects directly to something deep inside every human heart. Ever since our ancient ancestors sat around campfires looking up at the night sky, humans have always wanted to understand where we came from, how our home was built, and what our place is in this vast cosmic story. If the universe was completely smooth, featureless, and random, our presence here on planet Earth might seem like nothing more than a meaningless, lucky accident. But seeing that the cosmos is organized into colossal shapes, giant rings, intricate arcs, and vast connected webs, suggests that matter was guided by forces that drive complexity from the very beginning of time. These massive structures hanging quietly in the dark remind us that nature is far grander, stranger, and more surprising than our human minds ever dared to dream. Every single time we think we have finally figured out all the rules of reality, the universe presents us with a fresh mystery that forces us to stay humble and keep searching. The giant structures floating 10 billion light years away are silent monuments to the endless wonder of space, proving that the great journey of human discovery is really just getting started. If you want to stay on the absolute cutting edge of space exploration and be the first to know when the next giant discovery shatters physics, hit the subscribe button right now and click that notification bell so you never miss a single upload. Please drop a comment right down below answering this key question. Do you think scientists will need to invent an entirely new law of physics to explain these giant shapes? Or will an existing theory like cosmic strings finally save the day? We read every single comment, so share your thoughts and share this video with a friend who loves deep space mysteries. Thank you so much for watching, and keep looking up at the stars.